Welcome back once again. Now you saw how a default route works. It just matches whatever network you're trying to get to, okay, destination network, and it just sends it in that direction. All right. But now we're going to do actual, what they call now, static network routes. Yes, regular static routes, not static default routes. It's a static route. But now they want to call it static network routes. Okay. All right, so you put, instead of using a routing protocol, right, because that's dynamic routing, we're doing static. That means you are building the routing table. You are deciding which way the packet is going to go. Because you can have one router with two ways it can go, and depending on when you're configuring the static route, you know, IP route, destination network, destination mask, you can go out this interface, you can go out this network hop address. So it's up to you. You're determining the path. You are the algorithm of the router because you are creating that routing table manually. And this is where administrative distances start coming in. For a static route, well, first of all, the lower administrative distance, the more believable the route, okay? The more believable the route. In your chapter, they may have a different terminology, the more believable, okay? Or I'll say the lower the administrative distance, that's the one that's going to be in the routing table. That's the one the router is going to use, okay? So when you're doing static routes, by default, if you don't make any changes, okay, if you use the exit interface, it will look as if it's connected directly to the router, which in reality it is. You're using the connected interface. If you use the IP address of the next router's hop address, you cannot put the interface of the next router. If you put in the interface, it's because it's coming out your interface. If you put an IP address and you want to use your connected interface, and let's just, for an example, let's say your connected interface is 10.1.1.5. That's the interface is going out by, right? That's your router where you're creating the static route, and you try to put an IP address and say, can't do it because that's you. That's it's not your next router's hop address. So what's happening is the router is programmed, all right, to use either the exit interface, okay, meaning the F0, S00, S0, whatever the hell it is, okay, or the next router's hop address. Oh, 10.1.1.6, whatever it is, okay? So if you do use the next router's hop address, you will see an administrative distance of 1. That's the difference. That's it. But you see how low those administrative distances are? So if you were to do a combination, and we will later in the course, all right? If we do a combination of static and dynamic routing, due to the administrative distance, by default, okay, static routes will always win. When we get to dynamic routing, we'll discuss the administrative distance of those. They're larger than the static routes. So you can play around with this, and when we get there and do that particular lab, you'll see how we can use them in combination, static and dynamic and default together, all right? So now you know how to do the default routes, all right? Now you know how to do it between 2 routers. So now we're going to use 3 routers, okay? So we'll do default routes, let's say, on the outside routers. Still won't be able to get all the way across. All right, so we need to do static routes in the middle router. So the middle router tells that, hey, you got to go to this network, you got to go to this network, because routers only know who they're directly connected to, period. So static routes, just by thinking of that, means, if I do a static route and I'm working with like 1,000 nodes, hell, even 50 nodes, 60 nodes, 100 nodes, I'm not going to do that because they're all different subnets. That means I got to enter each subnet as, you know, put it in the routing table. Can you imagine that? And you make changes, and then you got to add or remove, you know, maybe you got to change direction. Well, it's a pain in the butt to do it statically. If you're working into, you know, mid-size to larger networks, small networks, not a big deal. But again, it's the amount of subnets you have. People think, oh, well, how many routers? Who cares how many routers? Okay, how many subnets do you have? Because every VLAN is its own subnet. So if you have 1,000 VLANs, that's 1,000 subnets, that's 1,000 entries in your routing table. All right, unless you're doing route summarization, which you've already learned how to do. Okay, and then but still, these are entries that if you're doing statically, you need to put in there. So you got to be very careful with static routing, because static routing is used in the real world, not only in your certification. They are used, and it's very easy to make a mistake. So in the lab now, I'm going to take you step by step, all right? But instead of having 2 routers, we're going to have 3 routers. And we'll play around a little bit in there. Cool? I'll see you inside. All right. Default routing. That wasn't too bad. So now we're going to go into actual, what they're calling now, static network routes. Static routes. All right. They just added the word network to it. Okay. Static network routes. And basically you, as I said before, you are the one that's creating the routing table. You are telling your router, say, hey, listen, let's say you're over here on this router. As we already know, we only know about, and let me put a label here so you know what we're doing. We're doing actual static network. That's what they call it now. Right? Static network routes. Okay, just so you know. All right, static network routes. All right, so now, routers, as you already know what you're connected to directly. So you got to tell it about the networks that it doesn't know. Well, this router knows about this network, the 1.0 and the 10.1.1.8, but it has no clue about the 10.1.1.4 or the 192.168.2.0. So you got to tell it, and you got to tell it how to get there. All right. And this router knows about these 2 networks, but it has no idea about these 2 networks. So you got to tell it about those 2 networks. And this router is the same thing. It knows about these 2 networks, but it has no idea about these 2 networks. So you got to actually go in there and build these routing tables, these paths, all right, on which way to go. And we're going to use static routes for that. Well, we're going to use static routes on this router and this router. But on this router, we're going to use the default route. So you can see that you can use a combination of both, okay? You can use a combination. You can actually, since these are still considered, there's only one way in and one way out of the network here. So you can use default routes pointing to this guy, default routes pointing to this guy, and he can have static routes pointing in that direction, or static network routes, I should say. All right, but it's completely up to you. All right, but just to show you that you can do a combination of both, okay? So we're going to move the lab over here, and we're going to open that router up. First of all, let's take a look. Remember I told you, get into the habit of looking. The computer already has the IP addresses, the 1.1, the gateway, the mask. This has the same thing. The IP address, the network, the IP address, the mask, and the gateway. All right, we go to the first router. Let's have a look, because everything is green, because I already configured all the basic stuff, which is just the IP addressing and host names and stuff like that. So you do a show IP route, and right there is telling you, hey, listen, I only know about the 8 network, and I only know about the 192.168.1.0. I have no idea anybody else. There is no gateway of last resort set. So if you're trying to get beyond, this point right here, you're out of gas. You're not going nowhere, okay? Because you have no idea about the 4 network or the 2 network. Okay. So what we're going to do is we're going to configure static network routes in order to do that. All right. Because if you go to each router, we'll look at each router. We can do a show IP in brief. All right. These are things I told you that you need to do, and then you can see if it's up, right? And it does show you up, or show protocols, so you can have the right mask, show protocols. And then, I like to do these commands just to make sure you know. See, you want to make sure that you have the right, right IP address for one. But you can see that with show IP in brief. But the mask, make sure you have the right mask. That's key also. Okay. So there's certain things that you need to do actually look at so you can understand your network and what's going on. All right. So we know what's going on. We know everybody's got their proper IP address. This is 9. This is 10. This is 5. This is 6. This is 254 on both sides. Obviously here it will be 1.254, here will be 2.254. And the PCs are .1s for their specific network. So we need to tell this router, because he only knows he's connected to 2 networks, but there's more networks that exist that he needs to get to. So we're going to do config T, and we're going to do IP route again, okay? But this time, let me bring this all the way out here. All right, IP route. I want to go to the 10.1.1.4 network. That's a 10.55.252 out my exit interface F0/1. Right? I'm not going to change the administrative distance to anything. Boom. Okay. I also got to tell it, hey, IP route. I want to go to the 192.168.2.0. That's 255.255.255.0 at that same interface, F0/1, because that's the interface I got to go out by. All right. And we'll do WR. And let's do a show IP route. And there they are right there, S's. SS means static, right? If you look at the code, S means static. So you know that we have static routes to get to these 2 destination networks right here. Now we can't get to it yet. We can't get to it yet. Well, let's find out, right? Let's say, okay, we got static routes. We should know now. We should know now where to go, right? Because if he knows where to send it, he's going to send it out this way. It's going to get to this router. Well, he's connected to the 4, so you should be able to get to the 4, but you can't, well, and this router knows about this, but he doesn't know about me. So what's going to happen? All right, let's find out. Let's go for gusto. 192.168.2.1. Let's go for gusto. You see it? Request timeout. Well, the network is busy. Network is busy. Let's see again. No, it's not going to get there. Not going to get there. Not going to get there. Because this router has no clue that this network exists. So let's do a trace search. Trace search 192.168.2.1. Let's see where we're going. Well, we get to the gateway. We know that. Okay, now we're having problems here. That's it. Done. You don't know where to go. All right, Control C. So let's ping. Ping 10.1.1.9. That should be our own connected interface. Awesome. Ping 10.1.10, right? That should be the F00 on router 1. Can we get to it? Remember, the network is busy. A lot of traffic flowing back and forth here. So we got to wait for it to, and maybe on the 3rd try it'll do it, right? We can do extended pings, right? We can source out the address, tell it how many pings we want, and we're having a flapping interface. No, it's just that the router 1 has to say, listen, you know, it's not going to happen because I don't know where, you know, you just can't get to it. It doesn't know. All right. So let's tell this router, hey, listen, there's another network that you need to know about. There's 2 networks you need to know about, actually. You need to know about the 2.0 and the 1.0. Let's see what networks this router knows about. Let's see. Show IP route. So this router only knows about the 4 and the 8. That's it. He doesn't know about the 1 or the 2, so he's going to say, I don't know where to send this. Okay? So we're going to tell him. Config T. All right, listen. IP route. There's a network, 192.168.1.0, that exists that you need to know about, 255.255.255.0, that we'll use the next router's hop address. You got to go to the 10.1.1.9. Okay? Oh, okay. So I'm pointing him this way because that's where the 1.0 is. If he wants to go to 2.0, I got to point him out this interface. So I'm going to do an up arrow. And I'm going to change that 10.1.19 to 10.1.16 because This guy's 10.116. This is 5. This is 6 down here. Okay? And it's going to be for the 2 network. Okay? UWR. Cool. Show IP route. All right, now he knows. You see, you have an administrative distance of 1 because we're using the next router's hop address. All right, so he's got to be able to get to it now. I mean, come on. You told him about it. He's got to be able to get to it. See what we get. Hey, look, now I can get to the 10 because router 1 knows about the 1.0 network. Okay, so let's go for Gusto. All right, get to the gateway. We got to 10.1.1.10. Awesome. All right. And lo and behold, request timeout because I can't get to that guy. All right, I can't get to that one. I can't get there. I cannot get there. He doesn't know about that network. He doesn't because he got there, but he just didn't know his way back because this router doesn't know about that network. So you got to tell this guy that this network exists, right? He knows already about these 2 networks. He knows about these 2 networks, but he doesn't know about this 1 network. All right. So what we're going to do is we're going to make it short and sweet. I said we were going to do a default route, and we are. We're going to do IP route. Listen, match anybody, okay? That's not even on your routing table. Any network, any mask. And just send them to the 10.1.1.5, okay? DWR. For a couple runs done for you guys, taking the exam. Show IP route. Gateway reference word is set. You see the star with the asterisk. That's what that means. You get an administrative distance of 1 because you're using the next router's hop address. Oh boy. All right. This is exhausting work. All right. Let's ping. Oh, we did trace it. Well, we got there. All right. Let's ping. Here we go. Now we can get there. Remember, echo request, echo reply. You can get there, but you may not know your way back because that router never had an entry for that destination network, right? Well, I got to send it back to the 1. Well, I don't know where the 1 is. Well, okay, well, let's send them a request timeout. But now, since we did a default route on the echo reply, they said, listen, just match any network that's not on our routing table, match any mask, and send it out. Same thing we learned in the previous lecture. So you can see that we can use a combination of static routes and default routes. And again, if you have redundant links or you have different links, there some faster links, you may want, if you have gig links, 10 gigabit links, 100 gigabit links, whatever the case may be, all right? And you want to point, your traffic to go out that way, right? Because you have redundancy to the same networks, but you have faster links. And you're doing static routing, you may want to, based on the administrative distances, hey, listen, send it out this way, okay? First, if whatever reason that fails, your second administrative distance will take over and take it out, the fast Ethernet interfaces with a gigabit, and then the fast Ethernet and then the Ethernet. So if you have different links and you have that redundancy, you can create multiple static routes to the same location, but just change the administrative distance of it and prioritize which way you want the traffic to flow, or you want certain networks to flow through certain ways, right? So let's say you got the design people, right? They're creating these huge AutoCAD, 3D, 4D animation projects. Well, you want them down to go to 100 gigabit, right? So you want to point that particular, say it's a VLAN, you want to point that particular VLAN to go out that way, okay? That particular network to go out that way, okay? And then, everybody else can go out another interface, what have you. So you can prioritize links so it won't take up bandwidth on other interfaces. But guess what that's called if you do that? If you have static network routes with different administrative distances. Those are called floating static routes. Floating static routes, okay? But you can manipulate traffic using static routes and send it in the direction you want. And that's the beauty of static routes. You have complete control because you're the one building a routing table. You're the one telling, hey, I want this traffic to go out the 100 gigabit link. I want this traffic or this network to go out the 100 gig. I want this traffic to go out the gig link. I want this traffic to go out the fast Ethernet. I want this traffic to go out the Ethernet. So you point it to the actual direction that you want. So it's secure. Not only is it secure in the sense that you can control if you want anybody to go anywhere, okay, or in which direction, but also you're not sending any updates, taking up unwanted bandwidth or anything like that, so people can be sniffing out updates out in the traffic. But if it starts getting bigger, if you start getting a whole bunch of subnets and stuff like that, like 10, 20, 30 subnets, now you got all these entries, and you got to put them on all the routers. Now, obviously, let's say this is Florida, New York, California. There should be an admin in every company, okay? They should be putting in their own static routes. But again, if it's too many subnets, it's just too much to handle. It's an administrative headache. Because you're the one that's creating the static route. And I can tell you from experience working in telecom that we did do a lot of static routes for the sites and stuff like that. And it's like you really got to keep good documentation, and you really got to pay attention. If you're doing 100 sites a day, you got to make sure that you're pointing things in the right direction. I can tell you I pointed things in the wrong direction I don't know how many times. So because people, real world, copy paste. Yeah, Alpha, we're using automation now. Yeah, we're using automation, but you got to program that, don't you? And you may just point it out the wrong way. I don't care if you're automating it, okay? You better know which way you're pointing it to, okay? Because, yeah, it may do it for you, but so does copy paste, and I still did it wrong because a person has to input that, okay? It's not, learning itself, okay? So know exactly what's going on, know your topology, know what has to be done, okay? Write things down, document things, know what's what and where it's going to and where it's coming from and stuff like that, especially doing static routes, okay? It's nice, it's easy, all right? No router overhead, that's great, but you better be very detail oriented to make sure that things are going the way they're supposed to go. Cool? That is static routes. That's how you would do it. Destination, whatever network you want to go to that the router doesn't know about, so destination network, that destination network's mask, and then it's either the exit interface, we use the next router's hop address. Okay? Those are static network routes. I'll see you in the next one.